Welcome to this video on generative artificial intelligence and its ethical implications. My name is Luis Felix, and the following presentation will cover the most important aspects discussed in the written report I have submitted as part of my individual project for the Generative AI course GAI 01 at SSBM. Before we get started, let me tell you a bit about myself. Once again, my name is Luis Felix, and I'm a current student in the MBA in Artificial Intelligence program at the Swiss School of Business Management. My background spans several years of experience in industrial processes, system analysis, automation, Internet of Things, and smart product support. In the last 5 years, I have led customer experience management projects for more than 50 digital products and support services at a global consulting firm. The topics that I will cover during this presentation include an introduction to the project, tools I applied, setup and development process, a live demo of the solution I created, recommendations for its refinement, ethical implications associated to my solution, and some proposed ethical guidelines to deal with them. Having said that, and without further ado, let's get started. In every industry, there is always a research area that is vital to the success of organizations these days, and that is customer experience. Regardless of the industry in which our economic activities take place, understanding the problems our customers face when consuming our products or services, and being able not only to quantify these processes but also to respond quickly to the feedback they generate has become an invaluable competitive advantage. However, the vast amount of data generated from user or customer interactions, the parameterization of their variables, and the subsequent analysis of this data require significant effort from analysts and consultants. With this problem in mind, my project focuses on the development process of a virtual assistant or chatbot assigned to the role of a digital user experience analyst. This allows any human analyst to streamline and expedite their tasks. To develop this solution, I applied my skills in Python programming and integrated AI models developed by OpenAI into my code. The AI agent I created was then granted access to the necessary data in CSV format, that is, comma-separated values. My agent has also been briefly trained on some key concepts of this particular field of knowledge, such as CSAT, which stands for Customer Satisfaction Score, CES, Customer Effort Score, and NPS, or Net Promoter Score, among others. The refinement process can include as much information as desired, as long as the AI agent continues to be enriched with various specialized information sources. At this point, I would like to make a brief parenthesis to add that although the presented use case falls within the field of digital experience management, the same solution I developed for this project can be easily adapted to other domains by simply editing a few lines of code in Python, specifically those that refine the knowledge-based sources and the prompt to interact with the AI agent. That and the fact that the code can be used both as a standalone application or be embedded into a larger application makes this solution highly scalable. When it comes to the tools I used to develop this solution, I can mention Python in the first place, which is an interpreted programming language with advanced data science libraries, Azure OpenAI, an advanced cognitive service offered by Microsoft, Jupyter Notebook, which is an open source web application used to write and document code, and IDLE, which is an interface development environment that is native to Python. It comes with it, so there is no need to install it separately. As already explained, the decision to use Python as the programming language and CSV as the file type to be imported stems from a very practical consideration. In real production environments, it would be extremely easy to integrate this code into other existing solutions that currently lack AI capabilities without major modifications to the back-end components. This means that the same code, with just a few slight adjustments briefly explained in the previous section, could be added as an additional function or feature in countless diverse applications. The development process of this solution took place in three different stages. Setup, basically the installation and provisioning of the necessary tools, libraries, and AI models, such as LangChain, Azure, OpenAI, etc. Coding, that included the writing of the code in Python and manually testing it in Jupyter. And then the integration test, which included running the script as a standalone application in idle and checking its results for validation purposes. This means that most of the code writing and debugging process was done in Jupyter, as it allows for quick and easy observability of the different logical parts that make up the solution. Now, the choice of this tool greatly facilitated the process of manually debugging and testing the software one feature at a time. For integration testing purposes, however, especially because of the improved readability, I decided to switch to idle. Now, let's briefly talk about the criteria I used to choose the best AI model for my use case. As of May 2025, here is a comparative table summarizing the key differences between GPT 4.1, GPT 4.1 Mini, and GPT 4.1 Nano models, three of the latest and most advanced chatbot models developed by OpenAI based on the latest information provided on their official documentation dated April 14, 2025. According to OpenAI.com, and I'm quoting now, GPT 4.1 Mini is a significant leap in small model performance, even beating GPT 4.0 in many benchmarks. It matches or exceeds GPT 4.0 in intelligence evals while reducing latency by nearly half and reducing cost by 83%. This is from OpenAI on April the 14th, 2025. We can see in this graph that OpenAI GPT 4.1 Mini has a much smaller latency than more advanced models, and yet its intelligence is quite up to par with them. After reading the documentation that accompanies their products, the GPT 4.1 Mini AI model seemed to offer, therefore, the best balance between intelligence and latency at a fraction of the cost of the GPT 4.1 model, which at the time of writing my report was offered as the flagship product from OpenAI. Now, for the fun part, let's have a look at the solution in action. By the way, as you can see, I made sure to include a lot of comments that explain section by section what the different lines do within the code itself in order to facilitate any future maintenance of the code and to improve its readability and understanding for other developers. The full code, by the way, has been made available in the appendix section of my written report. Let's just review the code very briefly.
The first section is for expertise customization. Mainly, I pass some very small knowledge-based articles that include concepts that we use in this space for the agent to be fine-tuned with them. The second section is the library import section. Mainly, I am importing pandas and some land chain classes that are required within the code to handle the data. In the next section, I am initializing the model I previously created in Azure, and then I am passing these CSV files that I previously downloaded into the downloads directory of Windows so that pandas can handle that data in the forms of data frames. In this section is where we do the prompt engineering properly by passing some prefix and suffix that frame the actual question that the user passes to the agent. It is precisely in this section where we tell the agent to take into account these articles that I created at the very beginning of the code. Then what we do is we um, launch the agent and allow the user to pass the actual question for the agent to find a response and bring it on the screen. Here below, you can see an example of an interaction. But in this screen, you can see the same code, but now we are working from idle, and you can see how this improves the readability of the code a lot. Now let's see the code in action this time. Once we run the code from this menu, this is what we will see. Uh, we have a prompt that uh, introduces itself as Dexter. That's the name of the agent, by the way. Hi, I'm Dexter, your virtual agent specialized in data experience data analysis. I'm ready to help you interpret your data and provide you with valuable insights about it. Do you have any question for me? So let's have Dexter answer a few questions for us. Um, can you please tell me what is the CSAP of the provided dataset? And then Dexter answers the question. The customer satisfaction score for the provided dataset is approximately 68.3%. This indicates that, on average, about 60.3% of customers reported an experience with the solutions that meets or exceeds their expectations. And then on top of that, the agent provides some recommendations because that is the way that we train the agent, right? In the suffix of the prompt, we ask the agent to provide recommendations on top of any quantitative data it can provide. So, and if we ask, okay, uh, now if we consider the other aspects, the other factors that impact sentiment, what would be the overall sentiment score and what can we do include it? And then it again answers the question. Overall sentiment score and important suggestions, it says, considering the key factors impacting sentiment score, sentiment, customer effort score, customer satisfaction score, and the net promoter score, the overall sentiment score is approximately 50.7. on a scale where higher is better. This reflects modern customer sentiment, making for improvement in or reduction, satisfaction enhancement, analytic thinking. And then it has a lot of recommendations for us to proceed. Um, you can see I have included here my my name and Mr. ID. Okay, and I'm letting everybody know that this content has been generated using AI. By the way, right? If you want to exit from here, you simply click no, and that will end this live.
I took the liberty to include this slide in my presentation, although this part is not covered in my written report. After I finished with my code, I could not stop thinking on how I could continue to improve the solution in the future. Well, the answer came to me in the form of RAG. RAG, or Retrieval Augmented Generation, is a framework that combines the strengths of traditional information retrieval with generative AI models. The way in which RAG works is very simple. By retrieving relevant information from external sources like databases or the internet and using this information to enhance the generation of responses. So first, RAG systems use search algorithms to query and retrieve external data sources from the internet based on user questions, just as ChatGPT does. But then, and this is where the magic happens, this retrieved information is incorporated into a pre-trained large language model so that this model can use the retrieved information to generate a more accurate, up-to-date, and contextually relevant response. This approach would lead to improved accuracy, enhanced relevance, up-to-date information, and increased user trust. I am leaving two paths of exploration open for future investigation here. The first option, which I briefly commented in my code, includes or involves indexing an existing cloud repository, such as a SharePoint library. And the second option, which came to me after I finished with the code, is connecting the deployed AI model with a storage service within Azure itself, such as blob storage, for example, uh, that may contain PDFs, Word documents, PPTs, images, etc., that the AI agent can feed from directly. Moving on, moving on into the next section, I will explore three key ethical implications to an AI solution like mine: potential biases in generated content, misuse of AI for misinformation, and the broader impact on human creativity and employment. Let's start with potential biases in generated content. For example, if a chatbot trained on biased data consistently interprets complaints from certain demographic groups as less urgent or less credible, it could lead to discriminatory service outcomes. This not only undermines the fairness of the system, but also erodes trust in the brand. To mitigate these risks, developers must implement rigorous bias detection and correction protocols, including diverse training datasets, regular audits, and human-in-the-loop systems to oversee critical decisions. Another ethical implication is misuse of AI for misinformation. Generative AI's ability to produce coherent, human-like text also opens the door to misuse. In the context of customer experience, this could involve the generation of misleading responses or fabricated testimonials in automated communications. While these actions may not always be intentional, the opacity of AI decision-making processes makes it difficult to trace the origin of such outputs. To address this, organizations must prioritize transparency and AI-generated communications. This includes clear labeling, of AI-generated content, maintaining logs of AI decisions, and ensuring that all outputs are reviewed for originality and factual accuracy before deployment. Third, the impact on human creativity and employment is also another ethical implication, since the automation of customer experience analysis and interactions through generative AI also raises concerns about the displacement of human workers and the devaluation of human creativity. While AI can efficiently process large volumes of feedback and generate responses, it lacks the understanding and emotional intelligence that human agents bring to customer service roles. Moreover, over-reliance on AI tools may lead to a homogenization of customer interactions, where responses become formulaic and lack the personal touch that fosters genuine customer loyalty. Businesses must, therefore, strike a balance between efficiency and empathy. This involves redefining roles to focus on tasks where human judgment is irreplaceable, such as conflict resolution, emotional support, and strategic decision making, while using AI to handle repetitive or data intensive tasks. Finally, to deal with those ethical implications, this section proposes a tentative framework based on four key principles: transparency, fairness, intellectual property and privacy protection, and the preservation of human creativity and employment. To ensure transparency in AI generated content, the first guideline would be businesses must clearly disclose when content is generated by AI and ensure that users understand the role AI plays in their interactions. To avoid biases in promote fairness, the second guideline would read AI systems must be trained and evaluated using diverse datasets, and businesses should implement regular audits to detect and mitigate bias. Then, to safeguard intellectual property and privacy, the third guideline would read businesses must ensure that AI generated content respects intellectual property rights and that user data used in training or analysis is handled with strict privacy safeguards. Lastly, to address the potential impact on jobs and creativity, the fourth guideline would read businesses should use AI to augment humans in their current roles and invest in upskilling employees to work alongside AI systems in lieu of replacing them. As we arrive at the conclusions section of this presentation, the integration of generative AI into customer experience analysis offers transformative potential, but it also demands a thoughtful and ethically grounded approach. Addressing biases, preventing misuse, and safeguarding human roles are not just technical challenges, they are also moral imperatives. As AI continues to evolve, so too must our frameworks for accountability, transparency, and fairness. Only by embedding ethical considerations into every stage of AI development and deployment can businesses harness the power of generative AI responsibly, ensuring that innovation serves both organizational goals and societal values. And While generative AI holds immense promise for transforming business operations, its deployment must be guided by ethical principles that prioritize transparency, fairness, privacy, and human dignity. The guidelines outlined in this document provide a foundation for responsible AI use, ensuring that technological advancement aligns with societal values and long-term sustainability. In other words, as AI continues to evolve, so too must our ethical frameworks. In case anyone would like to explore some further any of the concepts discussed in my project, I am leaving a list of reference sources for your reading pleasure here. I appreciate your time and attention. Thank you for watching this presentation. Please feel free to reach me in case you are interested in learning more about my work.